developing an assignment. So by the end of this faculty development program, you have to complete that assignment and upload it on the Google form that will float on the last day of this workshop. And on Saturday, we'll be keeping a test as it's already mentioned in the schedule of this FDP. So you have to be prepared for that too, and just make your notes during this whole program, and be ready with everything. Right. So, Ms. Arju, I once again welcome you for the day, and now the stage is all yours.
Okay, thank you so much, sir. Hello, good afternoon, everyone. I'll go ahead and share my screen. Let me know if it is visible. Okay, so yesterday we had gone ahead and we had understood what is Python all about, what is a working directory in Python. We talked somewhat about what are variables, and we also talked about what is an operator and how do we perform some of the basic operations in Python. We learned how to add, subtract, how to divide, multiply, make something to the power of something else, all those basic operations, how to perform those in Python. That is something that we saw. These are the basic operations that we had gone ahead and seen. Today, we are going to go ahead and learn a little bit more about these operators. And the first operator that I want to focus on is called a comparison operator. A comparison operator basically helps us understand the relationship between any two variables. So if I want to go ahead and I want to understand whether x is greater than y, x is less than y, x is equal to y, x is not equal to y, in all those cases, we go ahead and we use comparison operators. Now just see here that you are having x equal to y. This means I'm going ahead and checking whether the two variables are equal or not. Compare this with what we did yesterday. When I use a single equal to sign, it means that I am assigning variable some value. So when I say, okay, x should be equal to 4, that means I'm assigning the value of 4 to x. So when I use a single equal to sign, it is equivalent to assigning a value. But when I use double equal to sign, it's a comparison operator. It is used to check whether two variables are equal or not. You also have not equal to. Not is represented by an exclamation mark in Python. Greater than equal to, less than equal to, these are some of the comparison operators that we have. Another kind of operators that we have in Python is called the logical operators. When we talk about the logical operators, there are three main logical operators that we talk about. The first is called AND. So when we say A and B, it is going to go ahead and return true if both the statements are true. So AND means that two things should simultaneously be satisfied. So for example, if A is true and B is also true, then I will get the answer as true. But when A is true and B is false, so together I will not get the answer as true. So the AND operator gives a true if both the operands are true. The OR operator, on the other hand, gives true if either of them is true. The NOT operator, it returns true if both of them are false. So this is the three kind of logical operators that we have. I will shortly show all of this in Python to you also. The other operator that we have in Python, that is called as the membership operator. Now what are membership operators? So membership operators, as the word suggests, basically check whether a particular alphabet is a member of a sentence or not. A particular number is member of a list or not. A particular number is member of a set or not. So membership operator basically helps us to check whether something is present in something or not. So is A present in, let's say, hello? That's the membership operator work. Is H present in hello? That's the membership operator work. So it helps us to understand whether a particular thing is present in the other thing or not. Now let us go ahead and look at these operators. So this is the comparison operator. Let's have a look at it. I'm saying that let X be 10 and Y be 12. And now we are checking whether X is greater than Y or not. So I just say X greater than Y and I just run this command and it gives me false. So it gives me the answer in true or false depending on the relationship between X and Y. Then I check X less than Y. I again run this statement and I get the answer as true. I can check whether X is equal to Y or not. So notice that I'm using double equal to sign. So I just run this. Note that if I make X equal to Y, I run this, and now if I check the value of Y, it will be 12. And if I check the value of X, it will be 12. So basically when I said X equal to Y, this is assignment operator. It is assigning value. Whereas when I check X equal to Y, this is a comparison operator. So we have to be careful while using single equal to or double equal to. Most of it, we will always use single equal to whenever we are creating variables. Only when we are comparing the two variables, we would use a double equal to sign. Now we can go ahead and run this again and let us go ahead and check other comparisons. So let's say that I want to go ahead and check X not equal to Y. So this is the command for X not equal to Y. So this is giving true, which is correct because X was not equal to Y. If let's say I go ahead and I give different values to X, then they will not be equal to X and Y. If I give the same value, then they will be equal. Now again, you can go ahead and test X greater than equal to Y. You can test X less than equal to Y. So these are all the comparison operators that you can perform. Note that you can also use them in a statement. So you can also say print X less than Y is, so this is a statement that I am passing. I am passing this as a string value. And then after passing X less than Y is, then I am putting a comma and saying X less than Y. This is a comparison operator part. This within inverted commas is a string. So I am saying print and then I am saying whatever comes inside the string that will come as it is. And then I am putting the comparison operator and I am just running this command. So X less than Y, which is true. Okay, so whenever X is equal to Y, it means X takes the value of Y. So just remember this. When I was saying X is equal to 4, X was taking the value of 4. So when I say X is equal to Y, X takes the value of Y. So whatever Y is, that will be the value of X. So if Y was 12, so when I say X is equal to Y, since Y is equal to 12, it's like saying X is equal to 12. So X just takes the value of 12. Whatever is on the right hand side, that is the value that you're trying to assign to the variable. Okay. Any other doubt that we have in this? Okay. Now let's go ahead and look at the logical operators. So let's say that I give two values. I give X as true and I give Y as false. Now there is something which is very important here. Supposedly, you go ahead and you give X as true like this. And let's say that I want to run this. Note that it will give an error. It will say that this true is not defined. This is because if I go back to those keywords that we looked at yesterday, only true with capital T is defined. True with small t is not defined. So therefore, this is a key value. This is what the system understands. But this is not what the system understands. So we have to be very sure that when I write x is equal to true, I use the capital T. Now just let's replace this with capital T only, and let's see if this works. It does not. There are some languages which accept capital T as true also. But Python does not accept capital T as true. So again, this is the keyword that is defined by Python, and therefore we must use exactly the same keyword. So we are defining x as true, we are defining y as false, and we are trying to run this command. And now we are checking the logic. So I told you if one is true and one is false, the AND statement will say that it is false. But the OR statement is like either X is true or Y is true. So X or Y, that will go ahead and give me true. And the NOT statement will go ahead and give me the opposite of whatever the value of X is. So when I say not X, it will give me false. So whenever you have any logical operator, there are three: AND, OR and NOT. And will only give you true if both of them are true. So for example, if I keep this also as true, and now I check X and Y, it will give me true. So it gives me true if both are true. This gives me true if one of them is true, and not of X just gives me the opposite of X. Any doubt in this? Anything you think is not clear? Okay. Now, we also have something which is known as identity operator in Python. Identity operator is used to check if two variables are located in the same part of the memory or not. In a way, we are checking whether something which is there in one part, is it there in the other part also or not. Take an example. For example, I say x1 is 5 and I say y1 is 5. And now I want to check whether x1 is y1 or not, or x1 is not y1 or not. So what can I do? I can go ahead and I can say, suppose let's check first of all x1 is y1. Let's run this command. And it gives me true because both of them have same values. So I can go ahead and I can create an identity between the two, and I can say that, okay, the first variable is exactly the same as the second variable. So x1 is in fact y1. Now, if I go ahead and check x1 is not y1, it will give me false because this is a wrong statement that x1 is not y1. They are the same thing. Similarly, you can check whether x2 is y2 or not. So I can again go ahead and run this command and it will give me true. I can check it between two lists also, which I will discuss in a more detail later. So x3 is y3 and it gives me false. So these are some of the things that you can go ahead and do with the identity operator. You can go ahead and check whether the two things are the same or not. Now, if you notice, in the first case, when it was just a number and I checked as x1 is y1, it gave me true. When it was a string and I checked x2 is y2, it gave me true. But when I went ahead and I went to x3 and y3 and I checked whether x3 is equal to y3 or not, it gave me false. There is a reason behind it, and I will unwrap this reason after we do list in detail. Okay. Okay, yes, please tell me. You have any doubt? You raised the hand.
Out to be false, so that was the
Okay, okay, okay. So now the next thing that we can go to is the membership operator. Membership operator checks whether some variable or some value is in a sequence of variable or value or not. Now if you look here, I want to check, so X is basically hello world, and I want to check whether H is present in X or not. So I just say print, and what am I printing? Whether H is in X or not. I can also remove the print command altogether. I can simply say H in X, and that should be fine. So, when I go ahead and I run this, it gives me true because H is in fact present in X. Similarly, I want to check whether hello is present in X or not. I can go ahead and check that. If I in fact pass the reverse statement that hello not in X, then it will go ahead and check accordingly. So you can go ahead and you can check whether a particular variable is present in a string or not. A particular word, a particular alphabet is present in string or not. I just want to understand one thing here. Can you guess? So in X, which says hello world, hello is present. But when I checked hello not in X, it gave true. Can you think of a reason why? Well, because when we talk about hello, this is with capital H. And here I have hello with a small h. And the words are case sensitive. So when I check hello not in X, it gives me true because the one with small h is not present here. I only see hello with a capital H. So this is in fact a true statement. But the moment I go ahead and I make this as capital H and I check it, it becomes false because this is present in H. So when I say that this is not present in X, it becomes a wrong statement. Now, you also can check it for different categories of the variables. For example, this variable is a dictionary, which I will be discussing tomorrow. But when we do dictionary, on those dictionaries also, you can go ahead and you can apply the membership operator. So you can check whether a particular variable value is present in a variable or not. So I can check whether 1 is present in Y or not, as I can see 1. I can check whether A is present in Y or not, and so on. So membership operators in particular can be applied to any kind of variable. The variable can simply be a string value. The variable can be a full-fledged dictionary. It can be applied to any kind. The aim of membership operator is to identify whether a particular value or a particular variable is found in a sequence of variables or not. That's the role of the membership operator. Okay. Now, let us go to the first important kind of variable that we can create, and this is called a list. What is a list? A list is basically an ordered sequence of items. So when I go ahead and I, say 1, 2, 3, a list of integers. When I go ahead and say 2, 4, 6, 8, list of even numbers. So the list is basically an ordered, and the word ordered is very important because not everything would be an ordered sequence, but the list is in fact an ordered sequence of items. And one good thing about the list is that you do not need all the items to be of the same type. So you can in fact have a list which has mixed data types. And when I say mixed data types, I mean that within the list that I create, I can have a number, I can have a string, I can have any constant value, I can have floats, I can have integers. So basically a list has different kind of items that can also be clubbed together. The identity of a list is that it is shown with a bracket, which is a square bracket, and each element of the list can be separated using a comma. Now, the next thing that we want to understand is what is a nested list. So a nested list is any list in which you have a list inside the list. For example, take this example. Here I have a list 846. I have a list which consists of a string value A, and these two lists come with bigger list, which is the bigger square bracket that I have. When I have a list inside another list, it is called a nested list. So here this becomes a nested list. We also want to kind of understand what is indexing. Now when we talk about indexing, indexing means giving number to each item which is there inside the list. Now just go back and see here. We said that list is an ordered sequence of item. If it is ordered, we must give the order number to each item. And when we give that order number to each item, that exactly is called the indexing. There are two kinds of indexing that we can do. We can do a positive indexing. We can do a negative indexing. A positive indexing is when you start from the left and you go to the right. You start from 0. This is important. In Python, indexing starts from 0 and not from 1. So you start from 0, you go to 1, 2, 3, and so on. This is positive indexing. Each alphabet has an index and the index starts from 0. Negative indexing is when you go from the reverse side and you say -1, -2, -3, and so on. So negative indexing is going from the left hand side, picking up the first element, second element, third element, and so on. Positive indexing is going from the left hand side and saying 0, 1, 2, 3. So this goes from right to left, negative indexing, and positive goes from left to right. Now, why do we need indexing? A lot of times we want to go ahead and fetch a particular item from the list. So for example, here, if I want to fetch only 2 from the list, I want to go ahead and say my system, look, this is at the 0th position, this is at the first position, this is at the second position. Go ahead and give me the element that is there at the first position. So I want to fetch only one particular item or one particular element from the list. And since I want to go ahead and I want to do that, indexing of the list becomes important. I must know what is the position of each element. Another important thing about list is that they are mutable. Now when I talk about lists being mutable, it means that I can change the elements of the list. What do I mean by changing the elements of the list? It means that supposedly in this list, this element is 2. So I have 1, 2, 3. But now I want to change this element 2 to let's say 1.5. I can go ahead and change the value of a particular element within the list. Now this is a property which is only possible with list. It may not be possible with other things that I show you like string, like tuple. But lists are mutable. Their elements can be changed. Now we can also go ahead and we can do appending of list. And we can also add more elements to the list. We can also go ahead and add two lists together. So for example, consider this. I have a list which is 1, 3 and 5, But supposedly I wanted 7 also to be there in my list. So I will go ahead and use the command dot append, and then I will write 7. This will go ahead and add 7 to the existing list, and therefore my new list will be 1, 3, 5 and 7. I can also remove an element from the list, which I will show you shortly. So in order to add any element to the list, you just have to go ahead and use the command dot append. Now supposedly, I didn't want to add only an element to the list. I wanted to go ahead and add a complete list to this list. So supposedly initial list was 135, and now I want to go ahead and add this list 9, 11 and 13. Then because I'm extending my list, I will say odd dot extend. This will go ahead and this will add this part of the list to this part of the list. So your new list will have 6 elements: 1, 3, 5, 9, 11 and 13. This extend function can also be performed by using plus function. So for example, if I have a list 135 and I want to go ahead and add this part to the list 957 or 975, I will just use the command plus and I will write the new list and I will get the output as the combined list. So basically adding two lists is possible by the use of a plus sign, and it is also possible by the use of dot extend. Whereas if I just want an element in the list, I will use dot append. Now, when we go ahead and we add two lists together, like here, I had a list 135 and I'm adding another list to it 957, then adding two lists together is called concatenation. Concatenate in itself means addition. So concatenation stands for adding two things together. In this case, it is list. Now, sometimes we may want the same element in the list to come more than once. So for example, I may want that there is this list which consists of RE. RE actually stands for regular expressions. And now I want that this RE word, it should come thrice in my list. Then I will just use this multiplication sign and then I will just say into 3. When I will go ahead and multiply this list by 3, whatever elements are there in the list, it will come thrice in the result. So it will show me RE, RE, RE. So we can go ahead and we can replicate the items within the list. We can add two lists together. We can append an element to the list. We can also go ahead and delete some elements from the list. Now, if we want to go ahead and we want to remove a particular item from the list, we use the command pop. And if we want to go ahead and we want to empty the entire list, we use the command clear. So removing a particular item, you can use remove or pop, and emptying the entire list, you can use the command clear. Okay, now let us go ahead and look all of this in Python. Okay, now just see here. So here I'm creating a variable A. This variable A is a list. How do I know this is a list? Because I have square brackets and therefore it depicts that it is a list. Once I create a list, at any point of time, I can go ahead and I can also print the list. So printing the list would just mean printing this A. So I just say print A and I just run it and it gives me the output as this. Now yesterday we saw that we can use type word to check the type of a variable. So for example, if I want to check the type of the variable A, I can just say type A, and when I check this, it gives me the answer as list. Now, I can also go ahead and make mixed list. So this was a list which consisted only of integers. But what if I want to go ahead, add an integer, I want to go ahead, add string values, maybe I want to add some float values also. So if I want to go ahead and I want to add variables or elements which are of different types, I can go ahead and do that also. So I am creating another variable. The name of the variable is mixed list, and this consists of elements which are integer, strings and float. Let's just create this and let us just print this, and I will get this as the answer. So the list can have an integer, float or string within the list. Now, supposedly, I didn't want to create a list and then print it. I directly wanted to go ahead and print the list. So I can just create the list and I can use a print command on it, and it will simply print it. So in this case, instead of first creating the list and then printing the list, I am simply printing the list itself. I am printing this part itself. So this is like removing the task twice and doing it as one single command. Now, as I told you, there is also something which is known as a nested list. A nested list is a list of lists. So for example, here I have a list 1, 2, 3. This is a list in itself because the bracket starts and ends here. This is another list, good, best, better. And now there is a bracket here and here. So this is a bigger list, and this bigger list, it consists of two smaller lists, this one and this one. So now I can go ahead and I can create a variable. This variable is list of lists, and this variable has two lists inside it, and hence it is a nested list. And I can just run this command. And if I just go ahead and look at it, this is the output of this list. Please stop me in case you have any doubt or you're typing in and it is taking more time. Please let me know. Okay. So now we can also go ahead and read from the list. So as I told you, indexing of the list is possible. There are two kinds of indexing. The one is positive indexing and the other is negative indexing. When I talk about positive indexing, we start from here and end there. This is the 0th element, this is the first element, and this is the second element. So if I want to go ahead and I want to check what is the 0th element, I will just create a list and I will say A and then I will say 0. Now the square brackets here, these square brackets are used for the purpose of indexing or fetching an element from the list. So this square bracket, this is not a list, don't get confused here. This is not a list. This is saying I want to fetch the 0th element from the variable A. This variable A is a list in itself and I want to fetch the 0th element from it. So when I run this, I'll get the answer as 1. Now supposedly I want to fetch the first element. You can give it a try yourself. So let's fetch the first element. I get the answer as 2. And now let's fetch the element at the second position and I will get the answer as 3. So 0th position, first position and second position. Now I can go ahead and fetch a series of elements also. So what if I want to fetch the elements which start from the 0th position till the last? Now here is the thing in Python. Whenever we write a complete sequence of elements that we want to fetch, we can go ahead and we can say, okay, start from the 0th element, go till the 2nd element. But in Python, whenever we write it like this, whatever it ends with is not included. So if I write 0 to 2, it will include the 0th element, it will include the 1st element, but it will not include the 2nd element. So this is in fact excluded. So this is what I have mentioned also. The first starting point is included, but the second is excluded. So I can just run this command and I will get 1 and 2. What if I wanted 3 also? Then I should have gone ahead and written till 0 to 3. And I can run this and it will give me 0, 1 and 2. The third will be excluded. But now note that there are just 3 elements inside this at 0th, 1st and 2nd position. Supposedly I want to go ahead and fetch an element at the 5th, till the 5th one, nothing. Because it understands that only 0, 1 and 2 are defined. Anything beyond that, it will just give you the complete list. So here it will just go ahead and pass on to you the complete list. Now we can also do negative indexing. So, in this list, this is at -1, -2 and -3. So I begin with the first element from the last and I just run this and it gives me 3. Then the second element from the last. So I will write a of -2 and it will give me 2. Again, the third element from the last, you can just say a of -3 and it will give you the third element from the last. So at any point of time, you can do both negative and positive indexing. Negative indexing will be first element from the last, second element from the last and so on. But positive indexing will start from 0. So it will be 0, 1, 2, 3 and so on. Now, what if I want to go ahead and do this indexing within the nested list? So see here, in this case, there are only 2 elements in this list. This is the first element that comes before the comma and this is the second element that comes after the comma. So this nested list only consists of 2 elements, this and this. And let's say that now I want to go ahead and fetch the element at the 0th position. So I will write the name of the list and I will say, okay, I want what is there at the 0th position. So let's say and I got the first. Now, suppose I want the element at the first position, then I will get the next list. So if I run this, I will get the element at the second, at this position. But what if I want element inside element? What if I want to fetch inside this list? Then what do I do? Well, then I have to tell my system. So when I just wrote, so this is the 0th position. This is the first position. Now I am saying that after you go to the element at the first position, you give me this. But now within this, I want what comes at its first position. So this is the 0th position. This is the first position. So now this much gives me what comes at the first position. That's the complete list. And if within list I want again at the first position, I will again write this one with the bracket and this will give me better as the answer. So we can go ahead and we can fetch elements within the list, which is a nested list also. Again, for example, I want to go ahead and I want to fetch the second element of the list, which is at the 0th position. So, this is 0 and this is 1. So this part is saying that in the list of list variable, go to the 0th element, which means go to this list, 1, 2, 3. And then within that, go to its second element. So this is at the 0th position within this list. This is at the first position and this is at the second position. So it is going to the second element within the list, which is at the 0th position, and it is fetching 3 for me. So I am able to get elements within the list, which is in the bigger list also. Is there any doubt in this? Anything you think is not clear? Adding elements in the list is possible at the list index only. No, we can add one complete list to the other list if that is your question. I can edit the elements within the list, but whenever I will append an element, I will just use dot append, it will just add it at the last. Strings are written in single or double quotes, so we can go ahead and we can write strings both in single or double quotes. Even with triple quotes, strings are possible.
Ma'am, actually I was asking, so whenever we are adding the elements to the strings, so is it possible to add at the last index only, or we can start from index 0 also? Suppose 1, 2, 3 we want to add to 7, 8, 9. So is it possible in the beginning or at the end of the list? So that was the query.
Okay, so if you are adding one complete list to other complete list, it depends on whether you are appending A to B or B to A. If you append B to A, you will have the second list first. If you append A to B, you will have the first list first. That ways it is possible. Other than that, you can go ahead and also append an element in the list at a particular position also. So I can go ahead and say that, okay, I want my 5th position in the list to be filled by the element 4. That is also possible. And when you're adding two lists together, it depends on what are you appending to what. So, if I say x plus y, y comes after x. If I say y plus x, x comes after y. So that list takes the position accordingly.
Okay, thank you.
Now, lists are mutable. So when I say mutable, it means I can go ahead and I can change the elements of the list also. For example, if I look here, the 0th position of A is having the number 1. But now, if I just go ahead and say, so for example, let's say I just checked A0 and I got A0 as 1. Now I want that this should not be 1, but this should in fact be 10. What can I do? I can just say that A0, pick that element and give this element a value equal to 10. So I assign it a value equal to 10. And I just run this. And now let's say that I just go ahead and I again check A0, the 0th element. It will give me 10. Alternatively, I can check the entire list also, and the list will be 10, 2 and 3. So the elements inside the lists are mutable. We can change any element inside the list. We can also go ahead and add a new element to the list. So for example, if I just want to, add this word string new to the existing list, I can just use the word a.append, and this will go ahead and add new in the list. Now here is the thing. Whenever you talk about any smallest to smallest command or to the biggest command possible, you can always go ahead and use the function help to understand more about that component. So, even if we are doing the most rigorous machine learning technique, we can always use the command help and it will generate everything possible about that particular thing, and we can go ahead and look at what are the different parameters that the machine is using. So when I use the command help list, it tells me everything about what a list is. It is a built-in mutable sequence. It tells me what are the things I can do with the list. And if we keep on going ahead, it tells me, what happens if I go ahead and I change the size of the list? Can I go ahead and I can reverse the list? Can I go ahead and count the number of occurrences of a particular element in the list? Like for example, I told you we can use dot extend. Like for example, I told you we can use dot insert. So, these are all these things that we can use. I will show you dot pop right now. So these are all the things that you can go ahead and do. This is something which will remove a particular item. Then you can use remove, you can use clear. So all the things, all the commands that you can do with a particular module, you can access that by using the command help. Now let's go ahead and look at pop. So as I told you, pop is going to go ahead and it is going to remove a particular particular element. If I go ahead and I just use the word dot pop, but I don't give the index, I don't tell which element should be popped off, it will go ahead and by default remove the last element from the list. So I can say that make a new variable B. This variable B is the variable A dot pop, which means everything in A except the last variable, except the last element. So if I run this and let's say I just go ahead and I look at the value of B, it is going to go ahead and tell me what is it that it has popped. So it's the new that has been popped by default. Now, if I go ahead and I look at printing A, I will get 10, 2 and 3. Note that this happened because I did not specify any index for for what needed to be popped. I didn't give the position of popping, so therefore it went ahead and it simply popped off the last element from the list. Now I can go ahead and give the exact index also. So for example, I have this list 1, 2, 3 and I say a dot pop 0. So whatever is coming at the 0th element, it is going to go ahead and pop that. So I can just run this command. And now when I look at my A, it will be everything except the 0th element. So I will have 2 and 3 here. Now this popping can be useful when, for example, you want to remove a particular outlier from the list. Let me give you an example. For example, I am making a list of the age of people who voted. And I know that people below the age of 18 cannot vote. And now let's say that in the list, I have an element which is 13. And I want to remove this element from the list because, it is going to be an outlier to my list. Then I can just go ahead and use the command .pop, whichever index it is at, and then I can just remove that 13 element from the list. This is a very, very small example. Usually we will for outliers, we have a complete analysis, but otherwise .pop will help you to get rid of a particular element. Now, we also have something which is known as .count, and count helps us to count the number of elements in the list with its occurrence. So for example, I want to count how many times 2 is coming in the list. So I will just say a.count2 and it will tell me 1. Supposedly, I rewrite my list. I just use the command .count. It tells me that A comes thrice. Again, this can help you to get some kind of analysis. So if I give you a list of people with their ages and you want to go ahead and identify how many people of age 15 went ahead and voted, I can go ahead and use a.count15 and check what was the occurrence of 15 in my list. Now, we can also go ahead and create a list from a range. When I say range, it means that, I am just saying that take a range from 0 to 5 and just create a list. So I can say that my range is 5 and now I am saying create a list from the range. The range has to consist of the first 5 numbers. And I just run this and I get from 0 to 4. These are 5 elements that I have. Now, for example, I go ahead that look, I give you a range between 1 to 3. Remember that in range also, whenever you are using these brackets, the last element is always excluded. When I say the range is from 1 to 3, it will be 1 and 2. 3 would be excluded. So it will create a list of the elements 1 and 2. Similarly, if I want to go ahead and I want to create a list, but I also want to go ahead and I want to give the step that the list should take. So I want the list to start from 1 to go to 10, but I don't want to get all the elements. I want only the even elements. So I want a step of 2, or I just want multiples of 10. I want a step of 10. I can go ahead and do that also. So here, for example, I'm going ahead and saying create a list. The list is created from range. The range is from 0 to 100. So all elements from 0 to 100. But now I'm telling the third comma stands for steps. So now I'm going ahead and I am saying that only include at a step of 10. So when I go ahead and do that, it will include all the elements. Note that it will not include 100 because the last element is to be excluded. And then it will give me at a step of 10. So 0, 10, 20 and so on. So this is how we can generate a list from a set of or from a range of numbers. Can I add more elements between the elements in the list? We can go ahead and use dot append for it, and in the bracket we can go ahead and give exactly the index in which you would want to go ahead and add the element. Yes, that is possible. Can we extract the element from last position by using negative index in a list of list? We can do that because ultimately list is indexing everything. So the last element in itself is a list, but I can go ahead and I can extract the last position in that case also. Using append, it came at position 3. How to append at position 0? So when we use dot append, by default it will always go ahead and give it at the last. But if I go ahead and give the exact position of the element, I can append it at the last of the list also. Now, one thing that happens in this case is that so let me just show you. I'm not going to use the code dot append. I'm going to go ahead and if I just use append, it is going to be at the last, but there is a way where we can go ahead and add elements within the list also. Okay. in order to understand how any particular thing works, what you can do is you can go ahead and use the command shift plus tab. Whenever you will use the command shift and tab, it will tell you exactly what a thing does. So when we go ahead and talk of the command append and I pressed shift and tab, it tells me that append is always at the last of the list. So the append element in itself can only add elements to the last of the list. But let's say in order to kind of understand, we want to understand what to do if I want to add an element which is in between what your question is. So I can go ahead and I can use the command dot insert. So let's say I say a dot insert. And now I want to go ahead and let's say insert this new only. And let me just initially run A. So let's say initially my A is this. And now I want to insert this new, but I want to go ahead and insert this new at the first position. This is the 0th position and at the first position. So I will just go ahead and say 1. I will just press enter. And now I will just go ahead and say A and I will just run. So it would be added at the position where you want. Again, if you want to understand the role of any, so append and insert are doing the same thing. It's just that the one append is only adding at the last. Insert is able to add at any position. If you want to go ahead and understand what is the role of any command, you can go ahead and press shift and tab. And when you press this, it says insert object before index. So which means here it considers the index into B, whereas this does not consider the index into B. But the role otherwise is the same, to add elements to the list. Okay. Fine. So now let us go further and let us try to check an item in a list. So this is where we are going to use the membership operator that I was explaining you. Supposedly I create a list from a range 0 to 100 with steps of 10. And now I want to go ahead and I want to check whether 20 is present in the list or not. So we know that 20 is in fact there in the list. Let us go ahead and use the membership operator to check that. I just write 20 in list and I just run this and it gives me true. So this is how we can go ahead and work with membership operators. There is another very interesting thing that we can do with the list, which is concatenation with the help of a plus sign. So for example, I have this as my existing list. This list, I created it in this manner because of a specific reason. I wanted to show that not always will you see a list in a single line. It would be possible that you see a list with commas and it's spread across multiple lines also. However, it is doing the same function. It is exactly going ahead and creating a list. Now supposedly I created this list, shopping list, and now I want to create another variable called by the name another list, and this variable should do nothing, but it should just take everything from the first variable from the shopping list. I go ahead and I print these two variables. So when I go ahead and I print shopping list, it goes ahead and gives me these values. And because another list is also equal to shopping list, when I go ahead and print another list, that also gives me the same values. Now let's say that I am going ahead and I am adding cookies, and I am adding cookies to the shopping list. But what I am doing is, Okay, let me show it by both the ways. So let me say that I am using plus and I'm just running this. So my shopping list plus cookies is giving me this. Now when I go ahead and I print the shopping list, note that it remains the same because this variable was not given any value. I just added another variable, another list to shopping list, but I didn't go ahead and I didn't assign shopping list this new value. In case I want the shopping list to get updated itself, then I will go ahead and say that, look, my shopping list should be equal to shopping list plus cookies. And when I now run this, I will get it with cookies. So I must reassign shopping list to the two lists together. But let's check what happens to another list. So here I had given another list is equal to shopping list. Now let me just go ahead and print another list. So another list will not get updated because nothing happened to, I didn't write any command for another list. I made another list equal to shopping list above and then I reassigned some values to the shopping list. And now I'm just going ahead and I'm printing the shopping list. But what if I go ahead and put an equal to sign also here? And what if I add an equal to sign also here? And what if I now go ahead and I now print this thing again? And now I print another list also. Let me recreate the shopping list once. Okay, here it is. So what if I use the plus sign with the equal to sign and now I check what the values are. So note that when I use the plus and equal to sign together, it is saying that, look, I want to go ahead and add cookies to my list, but I don't want to only do it for the shopping list. I also want to go ahead and I want to do it for another list also. So I am adding this to everything that is equal to the shopping list also. And since another list was equal to shopping list, now when I go ahead and I print the shopping list and another list, both of them have cookies. So sometimes when we are using multiple lists together, and I don't want to go ahead and literally make changes to every list. I just want to go ahead and make changes to one of the list. I use a sign plus and equal to together, which means that I have to add this to not only the original one, but also to any list which was equal to that list. Now we can also go ahead and we can remove some elements from the list. So for example, if I clearly say that my list consists of strings and I want to go ahead and remove P, I can just run this command. And now if I go ahead and print my list, you will see that the output will be without P. I can also do a pop with giving exact element. So I can say pop at the first position. And whatever is at the first position from this list will be popped out. And now if I print my remaining list, it would be this. So you can remove your element exactly by mentioning the element name, and you can also remove it exactly by mentioning the element number, the index of the element. Now, you can also go ahead and you can clear the entire list altogether by using the command dot clear. So if I use the command dot clear and I now go ahead and I print my list, you will see that it will be an empty list because every element from it has been cleared. We can also go ahead and we can check the index of any element. So for example, I have a list of elements and I'm not sure where, for example, that age example. I have a list of ages and I want to remove anything which is less than 18, but I don't know where exactly 15th age is lying, where exactly that age is there. So I can check the index of any element in the list also. So I can say, okay, this is my list. Give me the index of 8. So it will go in the ascending order. So 8 is at the 0th position and the first position. So when I run this, it will go ahead and it will give me that it's at the first position. Now supposedly, I want to also understand how many times 8 is coming. So I can also count the number of 8 and I can understand that it is coming twice. So dot index, dot count, dot clear, these are some of the functionalities that are provided inbuilt by Python, and we just have to directly understand the role of each. And as I told you, at any point of time, you can enter shift plus tab and it will tell you that this returns the first index of value, which means it will always return the first one. You can always go back and check what the other things are doing. You can also go ahead and sort your list. So for example, if I want to sort my list, I will use the function dot sort. And if I now look at my list, it will be in a sorted fashion. I can also reverse it, which means I can sort it in the descending order. So I can use dot reverse. And when I do that, I will get my list in the descending order. This is all about list. There is just one additional thing that I want to discuss, and you can have a look at this part after we have learned a bit about the loops. So this is just from the point of view of loops. Now, once we do loops, we will understand that there is a for loop, a while loop, etc. Sometimes lists, they're most useful because sometimes lists help us to write a multi-line code using a single line. To give you an example, let's say that we have an open list. I'm creating an open list and now I'm saying take any variable x. This variable should be in the range 10, and after taking that, so range 10 means 0, 1, 2, 3 till range 10, and after taking that, just go ahead and do 2 to the power x. So 2 to the power 1, 2 to the power 2, 2 to the power 3 and so on. Starting from 0 because it is going from 0 and it will go till the 9th element because 10th would be excluded. So first 10 elements. This is what I am asking the system to do. Now this is a multi-line code. I make an empty list, then I say for x in this range, go ahead and add, keep appending the list by adding 2 to the power x. The beauty of list is that it can help us write this entire thing in just one line. It can simply say do 2 to the power x for every x in the range 10. I don't have to create any empty list. I don't have to write a complete for loop in 2 lines. I can do all of that in a single line. So list helps us to go ahead and to write the code in single liners rather than using a multi-liner code. If I run this and I print this, it will give me 2 to the power 0, 2 to the power 1, to the power 2 and so on. And even if I run this and I print, it will give me the same answer. So this is how lists can be useful. What will be the syntax to add any string at any position in the list, not only at the end? So you can go ahead and use the function dot insert that I showed to you. This. So I'm adding a syntax at position 1 in the list. If we need to know index of repeated numbers in a single command, okay. So in case we want to understand the repeated numbers in the single command, I will show you that. We can go ahead and we can write a loop for it, and we can say for every 8 that appears in this list, return the index of the list. So we will do that in a for loop. I will show you how we will get the index of each and every repeated element. Okay, so this was all about list. The next thing that we want to go ahead and cover is string. A string, as we now know, is any sequence of character. So for example, if I just write these simple English language characters, A, B, C, D, that's a string. Computers don't deal with characters. They only deal with binary numbers. So they only go ahead and deal with 0, 1, 1, 0, etc., etc. They only deal with binary numbers. That is the reason. Even when you pass a string to the computer will always save it as a Unicode of sequence. So for example, if I go ahead and I pass a string, this is my first lecture, computer would only save it as 2, 4, 5, 7, 8, 9, etc., etc. It will only save it in the numbers whenever any string would be passed. Now, strings can be created by putting them inside, as one of you were asking, in the single quotes or double quotes. Even triple quotes are used, but we very, very rarely will use triple quotes unless I have to write a multi-line string or a document string. I will focus on double quote or single quote. When we talk about strings also have indexing. I can do a slicing of the strings, which means I can go ahead and pick a particular element from the string. I can go ahead and do indexing of the strings. Again, it starts from 0. Supposedly, I go ahead and I try to access a character which is out of my string range. It will show an index error. I will again go ahead and show you how errors are there in string. Now, for example, let's say that I created a string which only had 10 alphabets to it. And now I'm trying to ask the system to give me the 15th alphabet in the string, the alphabet which is at 15th position. Well, that does not exist. So it will give me an error, string index out of range. Similarly, if I want to go ahead and I want to get a string index, make sure that it is only a number. It's only an integer. I cannot pass float values to get the value of a particular string. So I cannot say, give me the element at 1.5 position. It will either be the first position or second position. Strings are immutable. Like list, which was mutable, I could have changed the value. In string, I cannot change the value. So I cannot just go ahead and say that, okay, at the 5th position, just give the alphabet A. You will get an error that string objects do not support item assignment. Now, That's the reason why you have to go ahead and reassign the string altogether. So for example, if I gave the word Python and supposedly, I made a mistake and wrote M instead of N, I may have to write the entire variable again because I cannot just assign back one value in the string. We cannot delete or remove characters from a string, but deleting the string entirely is possible. So, if you go ahead and say, because they're immutable, so I cannot go ahead and change their position. Therefore, I cannot change any character. So if I go ahead and say delete my string 1, it will simply give you an error that string objects do not support item deletion. Let me just go ahead and show you strings now. Okay, so let's go to the first one. So if you see here, I have a variable my string and I am using single quotes to assign the value hello. And now I'm going ahead and printing my string. And I'm getting the value hello here. I can also do it with double quotes. I can also do it with triple quotes. It would all be equivalent. So for example, if I go ahead and I create my string 1, and instead of the single quotes, I am using the double quotes. I'm still getting the same. I can also go ahead and I can use triple quotes. And when I will run this, I will still get the answer hello. So single, double, triple, everything is fine. I can also extend my string to multi-variable. Multi-liner, sorry. So for example, I start with this line and then I go to the next line, that's fine. And it will just show me exactly as is. So hello, welcome to the world of Python can be taken to 2 lines. Now note that if I go ahead and I do something like this, it will just keep removing the gap. So I can have it in multiple lines being aligned to the left hand side also. Now, as I told you, you can go ahead and you can check the characters of the string. Indexing is possible in the string, but you cannot go ahead and you cannot do mutation in the string. So I can go ahead and say that, okay, what comes at the 0th position? So let's just make the string program as. And now I'm asking, okay, what comes at the 0th position? So I just run this command and it tells me that at the 0th position, I have the alphabet P. I can start from the negative indexing also. So I can say what comes at the minus first position and it tells me that at minus first position I have Z. Note that indexing process is the same in strings or list or any other item. I will always go ahead and I will always use square bracket for the purpose of indexing. So the indexing process is the same irrespective of the kind of variable that you are talking about. Now, you can also go ahead and you can get a series of values out of the entire string. This process is called slicing. So I'm saying, okay, give me the string 1 is to 5 and I just go ahead and get this. So this is at 0th position. This is at the first position, second position, third position and fourth position. Remember, fifth will not come. The last is excluded. Sorry, this first to fourth in this case. First to fourth character will come. The last one would be excluded. I can also go ahead and I can do a negative slicing. So for example, let's say that I say from the string 5 is to minus 2. So now just see, minus 2 means I'm starting from here. This is minus 1 and this is minus 2. And now it is saying go from 5 is to minus 2. And I told you that the last element would be excluded. So minus 2 will be excluded. I will only take minus 3 here. So minus 1, minus 2, and this is at minus 3 position, M. So this is my cutoff point. And where do I start from? I start from the fifth element. So 0, 1, 2, 3, 4 and 5. So at the fifth position I have 5 and I have to go till minus 3 because last will be excluded, which means I have to go till M. So what I will get will be M. So this will be my indexing. So I can do a positive to negative slicing also. I can do a positive to positive slicing also, negative to negative slicing also. All of that is possible. Now, for example, I just go ahead and give me the element which is at 134th position. Of course, there is no element at 134th position because there are just these alphabets in my string. So when I go ahead and I give this, it will just go ahead and throw an error that string index is out of range. Now, if I give, suppose I go ahead and give 1.5, or let's say even if you would have given 1.0, it will give an error because it will not consider 1.0 as 1. And it will simply tell you that there is no alphabet at 1.5 position. Either the alphabet is at 1 or it is at 2. So the string indices can only be integers, otherwise you will get an error. Let's say that I want to go ahead and concatenate the two strings together. So I have a string hello and I have a string world and I want to add these two strings together. So I will use the plus command directly. So this is not even required. This is just for getting the statement. You can simply say string 1 plus 2. So string 1 is this and 2 is this. When I say string 1 plus 2, I get hello world. Now, you can go ahead and you can also use the command print to show how this looks together, and this is how it will look. Let's say I want to go ahead and I want the same string thrice. So I can go ahead and say string 1 multiplied thrice, and when I go ahead and I do that, it will tell me hello, hello, hello. So I can go ahead and I can also get the three strings together. This is again a part of the loop. I will go ahead and do this again when we do the for loop. So this is when once we know the for loop. Just for your understanding, let's say that I want to go ahead and I want to understand, and this is very similar to what I was doing in this. I want to understand how many times a particular letter is coming in a particular string. So for example, I say begin with count 0, and now for every letter in hello world, such that the letter is L, which means for every L that comes in the hello world, add 1 to the count. So if it comes 1, you say 0 plus 1. Then it comes again, so you say 1 plus 1. Then it comes again, so you say 2 plus 1 and so on. So every L that comes in hello world, you go ahead and you add 1 to the count, and then you print count, comma, letters found. So if I go ahead and I run this, you will say, so count value becomes 3 because it kept adding thrice, and letter found was just a string value, so it printed that as is, and I get the answer that there are 3 letters found in hello world. So you can go ahead and you can count the number of times that a particular element is repeated within a particular string. Now, let's say that I have to get a mapping between each element and the index. So I want to understand that, okay, in this string code hold, what is the index of the element C? What is the index of the element 0? In that case, I can go ahead and I can, now combine two commands. Now you already know what a list is. So I want to generate a list. List of what? List of the enumeration of the strings. And what is enumeration of strings? To enumerate a string, it means that I want to go ahead and give each element along with its index. So this is what we are doing here. Let's say I just remove this. Just focus on this first. I am going ahead and I am saying to create an enumeration, which means to give each element in the string its index. So when I run this, and now I go ahead and I look at list enumerate. This is my list enumerate. So it tells me that this is at the 0th position, at the first position, second and third. Note that these are the elements that are coming inside the list. So we have 4 elements in this list. I would like you, please go ahead and give this a try. Find the indexing of this list. So you should be able to index this list. So find the index of each element of this list. So because this is a list now, so you should be, and its name is list enumerate. So you should be able to find what is the first element of list enumerate, second element, and so on. You can also go ahead and check the length of the list. So for example, of the string. So for example, I want to go ahead and check the length of the string. I will only use the command length LTR. And I will just pass this and it will tell me that the length is 4 because my LTR had 4 elements in it, cold. Now, as I was mentioning to you, we have single quotes, double quotes, or triple quotes for list, for strings. But here is the question. What happens if I want to go ahead and I want to use some inverted commas within the string? What happens if I want to use something like this? What's there? And this what's there is in inverted commas because the way that I want to write the sentence and not because it's a string. So I want these inverted commas to be very well there in the sentence. If I want this to happen, so if my string in itself has inverted commas, then I will use triple quotes to write the string. So if I go ahead and I do that, it will make sure that the inverted commas of this remain intact. So let me just go ahead and write it in double inverted commas and just run this. It will say error because now it does not understand where is which inverted comma ending. So if you have inverted commas within your string, make sure to use triple inverted commas outside the string so that it can identify this clearly. If you want to still go ahead and use double inverted commas or single inverted commas, then this one which is inside this inverted comma, it must be clear to the system that this is not where my string is ending. This is not a part of the string. This is a part of the sentence. And in order to make the system realize this, we will use single quote. So this is going to, this slash sign. So this backward slash, it tells the system that this part is not where your string is ending or starting. This is part of what is coming inside the string. So when I run this, it is going to print exactly here, same, and it is able to identify that this is just a usual part of the sentence. If I want to go ahead and use double inverted commas, then I must tell the system that this entire thing is actually a part of the sentence, and then outside I'm using the inverted commas to tell that this is a string. So whatever is part of the sentence, I am putting that in backward slash, and then I'm putting these double inverted commas outside also, and I'm just running this and I'm getting the same answer. So there are multiple ways to make the system understand that there is a difference between the inverted commas that come inside the string versus the inverted commas that tell that this is a string in itself. So we just have to be a little careful if our sentence in itself has some inverted commas. Okay. Any doubt that we have in this? All right. So then I will move to the next part, and this is sets. The sets are very, very similar to the set theory that you would have, seen in your, I should say, school life. It is very, very similar to that. So a set is an unordered collection of items. Every element in the set is unique. So, if I give the same element twice or thrice in the set, it will just take it once. In that sense, it is unique. And it is immutable. So, I cannot go ahead and I cannot change that element. But the set itself is mutable, which means I can add or remove items from the set. So see that in string, I wasn't even able to add an item or remove an item from the string. Here I am able to add or remove items in the set. Sets can be used to perform various mathematical operations like union, intersection, difference, etc. If we have to create a set, then all the items in the set must be created inside curly brackets, and they must be separated by the comma. So see that each of the type of variable has a specific way in which we write that variable. When it was a list, I was using square brackets. When it was a string, I was using double quotes. When it is a set, I am using curly brackets. So each of them has a way in which it is written. Also, they come with a built-in function. So if I don't want to use these curly brackets, I can very well go ahead and use the function set, and that will help me to create a set. It can have any number of items in it, and it can be of multiple types. So for example, I can go ahead and have integers in it, floats in it, string in it, anything. But a set cannot have a mutable element inside it. This is very, very important, and I will show this to you. Anything, so for example, I showed to you that a list can contain another list. A set can contain another kind of variable as long as that variable is not mutable. If the variable becomes mutable, for example, a list is a mutable element, then a set cannot contain a list inside it. For example, a dictionary that we will do tomorrow is mutable. So a set cannot contain dictionary inside it. So a set cannot contain another element if that element in itself is mutable. Sets are mutable, but since they are unordered, we cannot go ahead and give any indexing to it. So note that when I was talking about list was ordered. It had some positioning 0, 1, 2, 3, etc. And when we were changing the elements found at a particular position inside the list. Unlike that, when I talk about set, set have no orders. So a set, you cannot go ahead and say that what is at the first position or what is at the fifth position. No order exists. We cannot access or change an element of the set using indexing or slicing because there is no index per se. We can, however, add elements to the set by the method of add. And we can also go ahead and add multiple elements in the set by the method of update. We can also go ahead and remove elements from the set by the method of discard and remove. Now, both discard and remove, they go ahead and they perform the same function other than the fact that we can use the function discard even if an element does not exist in set. So for example, if set has elements 1, 2, 3 and I say discard 4, it will not do anything because 4 did not existed. But in case of remove, if a set has element 1, 2, 3 and I say remove 4, it will throw an error. So discard will never throw an error and remove will throw an error. That's the only difference. Otherwise, you can use discard or remove interchangeably. Now, just consider these are the two sets that I have created. So the first set is 1, 2, 3, 4, 5. The second set is 4, 5, 6, 7, 8. On these sets, I can go ahead and perform various operations. Operations like union, intersection, difference, symmetric difference. What is a union? A union is in which you take all elements of A and all elements of B. So when I say A union B, it means I am taking the elements of A and I am taking the elements of B. Now whether I do A union B or I do B union A, it is the same thing because it will take all the elements of the two sets together. Intersection. Intersection is where you go ahead and you take the common elements between the two sets. So if I say A intersection B, because only 4 and 5 were common between two sets A and B, I will get the answer as 4, 5. Again, I can use it interchangeably. So whether I say A intersection B or I say B intersection A, I am actually meaning the same thing. Let me just go ahead and show you this in code now. Okay, so we would be going ahead and we would be doing tuples tomorrow. It is a separate kind of variable that we create. I think so I have answered other ones. So now let's go ahead to the set theory. Okay, let's say we begin with this set. How do I know it is a set? Because it is within the curly brackets. However, at any point of time, I can go ahead and I can check the type of this variable. So when I check the type of S, it gives me the answer as set. So it's a set. Now, note that here, so I will just want to compare this with the list. So let's say I'm creating this as S and let's say this is B and I'm going to print B also to you. Note that when I talk about S that I created, this is a list that I made. In this list, each element comes as is. So even if I'm repeating one thrice, I will see that it comes thrice. But if I am creating a set which is created using curly brackets, you will note that when I print B, I only see them coming uniquely. So I only see 1 coming once, 2 coming once, 4 once, and 5 once. It does not take repetitions. That's the first thing. The second thing is, if I go ahead and I say, give me what comes at the first position in S, it will give me 1 because this is 0 and this is the first position. But if I go ahead and I say, give me what comes in the first position of B, it will throw an error because it is a set. And because set just took the unique elements, how would I know the position which is at the first one? Because according to this is 0 and this is 1. So 1 should be the first position. But according to this is 0 and this is 1. So 2 should be at the first position. So because it is only taking the unique elements, the order automatically gets shifted. There is no order per se. Ideally, it is an unordered element. So indexing of the elements is not possible. I cannot go ahead and say, give me the element at this position. That would not be possible. Now, let's say we want to go ahead and perform some of the union and intersections. A union is one where it is going to take all elements of A, all elements of B, but make sure that there will be no repetition. So even if 4 is coming in A and B, it will just take it once. In order to give the union between two sets, it is given by this operator, which is a line. So I just say print A union B and it will give me all elements of A and B. Let's just run this. And I have all elements of A and B together. An intersection is one which is only going to give me the common elements between A and B. And because it is going to give me only the common elements between A and B, I am going to use AND between A and B. So when I go ahead and write AND, it says what is present in A and in B. So only 3 and 4 are present in both A and B. So I get the answer as 3, 4. We can also find the difference between the two sets. So when I say A minus B, it means subtract the elements of B from A. So when I remove the elements of B from A, what was there in A and B both? 4 and 5. So if I remove B from A, it means I'm removing 4 and 5 from A and I will get the answer as 1, 2, 3. Note that if I would have written instead of A and B, B and A, I would have got the same answer, whether it is A and B or B and A. But when I go ahead and when I do A minus B and I do B minus A, of course I will get a separate, different answer. So when I do B minus A from B, it is subtracting A. So if I subtract the common part, the part of A, I'm left up with the remaining one, which is going to be 5 and 6. But when I do the other way around, it is going to be what is left in A. So A minus B and B minus A are going to be two very different things. This will be 6, 7, 8. This will be 1, 2, 3. A set, as I mentioned, cannot have a duplicate. So even if I have duplicates and I print the set, it is only going to go ahead and take unique values inside the set. Now, this is what I was mentioning about. A set cannot have any item which is mutable. So let's do an experiment. Let us go ahead and let us create a list. And inside this list, Let us go ahead and create a set. I have a list, and inside this list, how do I know it is a list? Because it is given by square brackets. And inside the list, one of the element is a set. And I just go ahead and run this. And now I just print my list and I will get all the elements as is. Now I revert it. I create a set and inside the set I create a set, and you will see that it is going to go ahead and give an error. Let's say I create a list inside a set. It will give me an error. It is saying me that so because this list was mutable, I can change the elements inside the list. I cannot have a list contained within the set, but I can have a set contained within the list. So a list in that sense is a more easier thing to work with because it can, I mean, the functions are absolutely different, but when it comes to containing mixed items, containing items which are, nested one among the other, a list within the list, a set within the list, a tuple within the list, I can do that with list, but I cannot do that with set. Now, as I was mentioning to you, you don't have to always use curly brackets to create the set. You can also go ahead and use the command set to create the set. So if I go ahead and I do this, I can get the set. Here I did not go ahead and use my curly brackets. I just told what are the items that I want in my set, and I used the function set to create that set, and I got the elements. This I've told, it will show an error if I try and create a list within the set. So a list is mutable, which means I can add elements to it, I can delete elements from it, but the list does not have indexing to it. So I showed you that if I go ahead and I check the element at the 0th position within my set, I will go ahead and get an error. So a set cannot have any indexing attached to it. However, I can add more elements to the set. So for example, if I say that initially my set is 1, 3, and now I say dot add 2, it is going to add 2 to my set. And when I go ahead and print my set now, it will be with this additional element 2. Note that it will always give you the results in ascending order. Okay. I can also go ahead and I can add multiple elements in my set also. So for example, if earlier my set had these elements 1 and 3, and now I want that 2, 3, 4 should be updated to my set, I will use the command dot update. So I use the command dot add when I just want to add a single element, and I use the command dot update when I want to add multiple elements. So I want to go ahead and add all these 3 elements to my earlier set. So I again initialize this set. It has 1 and 3 in it. So now I just update it with 2, 3 and 4. And I now print again my set. And you will see that I now have 1, 2, 3 and 4 in the set. Now you can also go ahead and you can update your set with a particular list. So for example, something like this. Let's say that I have, let's create again the same set. I have this set 1 and 3. And now I am saying I want in this set two things. I want the elements 4 and 5 from a particular list, and from another set I want the element 1, 6 and 8. I am not going ahead and putting this list inside the set. In this case, I am just going ahead and I'm updating the elements of the list inside the set. This is possible. Updating more elements from any list, from any set is possible, but doing a nested set, that is not possible. So if I just go ahead and say update this set with two things, one is the items of the list and other is the items of the set, and now print the set, I can run this command and it will have all the items. It has 4 and 5 now in this set. It has 6 and 8 also in this set. So this becomes my new set. I can also go ahead and remove the elements from the set. So supposedly initially my set is 1, 3, 4, 5 and 6. And now I want to just discard the element 4 from the set. So I will use the function that this is my set. This is the variable I had created my set. And now I use the function dot discard. And what do I want to discard? I want to discard 4 from the set. And again, I want to print my set now. So when I run this, I will get the set without 4. Similarly, I can also go ahead and remove a particular element. So I want to remove 6 from it. I told you both the things do the same thing. So if I just say dot remove, it will just remove it and your set will now have 1, 3 and 5. Now supposedly, I want to check the difference between the two. So I go ahead and I say dot discard 2. 2 is not there in this set, but when I say dot discard 2, it will just give me the same set but not throw an error. 2 was not there, it did not make any change and gave me back my initial set. But let's say that I say dot remove 2. Now 2 was not there and remove will give an error. So when I run this, it will give me an error saying that it did not have 2 in it. So therefore it could not remove 2. So discard and remove do exactly the same things. The only difference is that when I talk about remove, if an element is not present, it throws an error. When I do discard, even when the element is not present, no error would come in case of sets. Okay, sure. Thank you for the suggestion. I can definitely go ahead and I can give you some problems and we can do it in every 30 minutes. So maybe tomorrow when I do tuples and I do dictionary, I can get those sessions and we can try and solve those sessions. Okay. Anything else, any doubt you have, any feedback that you have for tomorrow? Okay. So this is it that I wanted to cover in today's session. So for today, we have gone ahead and we have tried to cover 3 things. One is a set, one is a list, and the other is string. Each of them come with their own properties. Lists are extensively used because they are mutable. Indexing is possible. Appending is possible. On the other hand, when we talk about sets, they cannot be they are non-mutable in the sense that I cannot have any indexing done in them, so I cannot remove an element from a particular position, but I can still add or delete some elements. On the other hand, in strings, they're completely immutable. I cannot do any editing with the strings. Okay, if there is any doubt, I can now take those doubts. Okay, then we can wrap up for the day. I will go ahead and share an assignment with you. The assignment would be based out of these three concepts. And I will also share the code that we discussed in today's class so that in case you missed out on something, you can run the code. And I will share the lecture notes relevant to these three topics.
Right. So, guys, we are closing for the day, and I'll be sharing the content on the WhatsApp group only.